Yes, I am.
Okay. So we'll just put that here.
Awesome. Good
Clean the
morning,
wine from
everyone.
last
I'm Palak, and I'm a climate tech investor at Plug and Play. And we have an exciting 30-minute session planned for you today. So we'll be starting off with learning about what exactly is Plug and Play. I'm sure you've seen it on the agenda, and you're like, what is that? So no worries, I'll answer those questions. And then I will talk a little bit about the water investment landscape and do a specific deep dive. And following that, we'll hear from 3 amazing startups on really great stuff that they're building within water tech. So to begin, Plug and Play, in the simplest words, is the world's largest innovation platform. So we are 700 employees strong across 65 offices globally, and our mission is really simple. We connect the world's best technology startups to the world's largest corporations. And we have been doing that for 20 years now. And in these 20 years, we've built a database of over 100,000 startups that our Plug and Play staff has personally interacted with. So for more specificity, we do venture capital. So we are a venture capital firm investing in pre-seed to Series A startups, so super early stage, and we do so across 26 different verticals. Sustainability is the vertical I work at, and water falls within our purview. The next part of our business is the Open Innovation Platform, and that is where we interact with over 500 plus global corporations. So think big names like Walmart, Intel, Pepsi, but then also more industry-specific ones. And essentially, we are connected to their innovation teams. And whenever they're looking to explore new technologies, we help educate them on those trends and also connect them to the right startups for some sort of commercial agreement, whether that's a pilot, POC, JDA, whatever that looks like for them. And then finally, we also have accelerator programs, which are usually run by Plug and Play and are vertical or location specific. And sometimes we also run accelerators for other corporations, like most recently, we are helping run the Amazon Climate Tech Devices Accelerator. So in terms of investment, where my role primarily lies, we've done close to 100 investments within the sustainability vertical. So these are some of our portfolio companies. Since 2019, that's when the sustainability vertical was launched. And because of the success our portfolio has had, we've been named among the top 50 climate tech VC firms. So as you can imagine, with the big database that we have and the number of startups that we interact with on the daily, we are really sitting on this gold mine of proprietary data, and we channel that data into our trend reports. Now, those trend reports are exclusively available to our corporate partners as well as LPs within our investment funds, but these are just some of the topics that we have within our vertical. So we're actually making an exception today, and we'll be giving you a sneak peek of our latest water trend report, and that is about how data centers are redefining water investments. And yeah, unfortunately, more AI for all of you. And I'm sure I'm not the first person who's the only person that's gonna talk about data centers today. You're gonna hear it all throughout the day, and the reason is because data center development is happening fast, and we are in a water-stressed region like Arizona. And it is really interesting to understand the dynamic that is playing between these two things and what innovation is happening at that intersection. So before we get into data centers, just looking at the investment landscape within water, I think most of us in the room know or have an inkling that water is an underinvested sector, right? But not all hope is lost. In 2023 and 2024, the average fundraising within VC was about $800 million per year, compared to just $400 million. That was the yearly average between 2018 and 2022. And obviously, we know there's a major infrastructure funding gap. McKinsey said that gap was $110 billion back in 2024 and is expected to almost double by 2030. So here are some of the trends that we think are going on in the water VC space. There are some spaces to watch, some spaces that have been doing well and will do well in the future, and then there are some spaces that are fading out. So in terms of fading out, I'm going to say reverse osmosis, smart irrigation, and then direct-to-consumer technologies. I'm not going to go into the specific reasons because I'm short on time, but if you disagree, please come and talk to me after the session. But going to the here to stay category, thinking about industrial water treatment, we've already heard, industrial water treatment is important, right? Manufacturing, energy, food, all these industries discharge water, and that needs to be treated, and there's a clear compliance related demand there. And then there's also potable reuse, and before there was less acceptance for it, but as more and more cities are experiencing supply shortfalls, it has gotten some regulatory acceptance, and I think that's only gonna go in the positive direction, as well as, as people understand our future water risks. And then finally, there's ocean tech. There's always been this sentiment around our marine well-being, and with desalination costs down, I think there's a lot of innovation to happen in that space. And then finally, the spaces to watch. The first one is AI-assisted water intelligence. So that's really, startups that have software or sensor platforms that can use machine learning to predict failures, optimize treatment, and also just give you visibility into the larger distribution networks. And if a startup is doing that well, I think that is definitely going to be really rewarding for the sector. And then again, there's alternative resource recovery, which I think Dr. Ridman has already covered, so I'm not gonna go in there, but you all know the value of that. Again, a very exciting space to watch. And then finally, there's data centers. Again, very big in driving funding towards water tech. So here are some stats around data centers. So the US today has about 4,000 data centers, and that is expected to get to 10,000 data centers in 2030 and will require about $7 trillion in CapEx investment. But forget about the new data centers that are gonna come online. A single large data center today uses 5 million gallons of water per day, which is the equivalent of the water consumption of 50,000 people. That is a town worth of demand. And think of that as, that's not a standalone thing, that's being replicated hundreds of times across the country and in water-stressed regions like Arizona. So there's obviously a need for innovation. In terms of the data center venture landscape, so looking at the macro trends in data centers, funding went from $650 million in 2020 to nearly $10 billion in 2025. So there's a lot of cash flowing into data centers. And luckily for us, cooling is the #1 investment category. So other categories like energy systems, digitalization, IT efficiency, they're all obviously big topics, but then most of the funding is going into cooling, which is great because it is the single most water-intensive, energy-intensive, and critical function within a data center. It has gotten about close to $8 billion in funding in over 300 deals over the last 6 years. So before I go into the cooling startups themselves, I want to give a really compelling example of the startup called Crusoe. It's a startup that was founded in 2018, and their primary function was to capture waste gas from oil rounds. So it was a 4 million seed round and a 30 million Series A round that followed it. And those are pretty standard fundraising rounds for a climate tech startup. However, over time, they started pivoting more and more into AI infrastructure. And if you see the news snippets that I have, they raised over 100 million in 2021. That became 200 million in 2023, and then 600 million in 2024. And then last year, they raised 1.38 billion in a single funding round, which was their, I think, Series E. And they've been funded by big players like NVIDIA, Goldman Sachs, Salesforce Ventures, Founders Fund, with a total of $4.2 billion across VC and debt financing. And this is really an example where a simple climate mitigation play, when found a use case within AI and really capitalized on it, and now they've become one of the top startups in this space that has received so much funding. And we're gonna see a lot more of this happening across the board in various sectors, including in water. So finally, this is a quick market map, which we did on the cooling startups within data centers. We divided them into 5 categories. Obviously, I don't have time to go into all of these startups, but what I do want to say is that cooling innovation is not happening just for the sake of it, right? So if you take the example of NVIDIA chips, the really early generations, so take the one that's called Hopper. I think it came out a couple years ago, and with Hopper, your basically air cooling was fine within data centers, but then they released a new generation, which is called Blackwell, which is 50 times more powerful than Hopper. And then people started pivoting to liquid cooling because air cooling was just not doing it anymore. And then apparently the next generation that's going to come out, it's called Rubin, I think, and that would have to be 100% liquid cooled just because of how powerful it is. The next set of startups we have are water startups that are outside cooling, but then still essential to the data center landscape. So the first category is sourcing, and the other one is circularity. So within sourcing, obviously a lot of data centers are not trying to tap into the portable supply to get their water, so treatment and purified water has become a big deal. And that's where existing players like Gradient, which is a water tech unicorn, they come into this and they're doing pretty well because of this added revenue stream. And then there's a new set of startups that are coming up in the atmospheric water generation space, where basically you're pulling moisture out of the air to create an off-grid source of water almost. And those would be really important for data centers. And then finally, moving on to the circularity space, closed loop and zero liquid discharge technologies we're seeing a rise in just because a lot of data centers and regulations are mandating either little to no wastewater discharge out of data centers. So there's going to be a lot of activity there. And then finally, there's that water intelligence layer where there are startups that are giving you visibility into how water flows through your facility or through your larger distribution networks, so that you're able to make informed decision making, whether it is for current data centers or for new construction that's coming up. So I know I said a lot in a very short amount of time, but if you have any questions, please come to me after this session. But now I'm gonna shut up and pass it to the startups. So the first startup up is Nona Technologies. They're an MIT spinout. We have Ben here today to tell us more, and they're doing great work in the data center space. So yeah, Ben, why don't you come up?
All right, thank you. I'll not talk too much about data centers, but there's plenty of that. So I'm Ben. I'm a founding engineer at Nona. What we're doing, we actually mentioned just previously, is lowering the water footprint of companies that use a lot of water, so a lot of cooling. I guess you guys know this, but AI uses a lot of water, and that is primarily through cooling, using evaporative cooling towers, which I will say, just so we're on the same page, basically what happens is there's a loop of water that's cooling all of the equipment in the data center that is sprayed on a panel on the roof, and then through that latent heat, right, the water evaporates and removes that heat. So what happens when you evaporate water, it gets saltier and saltier. This is just tap water, right, coming in. So we get more and more salt. At some point, that's too much salt. and they have to dump it. That happens like every 30 minutes is, several hundred gallons are just dumped. So what we do is we're able to basically cut that water consumption for the data center by 50%. So that's using our proprietary technology, which I'll get into more, but what we do is we take 90% of that water and we send it right back into the system. So you're only dumping that 10% and saving on chemicals and sewer costs. Of course, reducing the impact also of the water use. So what we do is we have 3 patents on ion concentration polarization that was invented by our CTO. What this basically means is that we are sort of an electromagnet to the salts and the charged particles in water. So we're not using high pressure like reverse osmosis, or we're not passing things through the membrane, right, which can lead to fouling and clogging and things like that. But rather we concentrate the stuff, the salt, right, to one side of the membrane, and that actually lets us mechanically remove that, right? So very low touch process, right? And we have 3 patents on this that are exclusive use. So that's sort of the goal of our company. So just to give you a quick idea of what this looks like in a data center is this sort of machine here that you see on the roof, that just plugs into the loop of the cooling tower. So water in and water out and sewer. So it's quite a simple integration as far as the equipment is concerned, and the savings are a quick payoff, right? A few years. You save that water, right? And then your savings are from sewer costs, from lower chemical use. So the math is not too bad. It's a few-year payoff. We've already tried this, actually. We have two deployments that I'd like to talk about. So one is with Tracy Renewable Energy. That's a power plant in California, also a water-stressed area. We're using their cooling water, sending it right back into their system. And then the other one is the Baltimore Air Coil Company. That's the leading manufacturer of these cooling towers. So they're very interested. They know it's a problem. They know there's savings here. They know their clients want it. So this is our team. I used to work at JetCool, so I was on the other side of the liquid cooling. And then we have our CTO. He invented it at MIT. He's been working on this for many years. And we also bring in some experience from Rivian as well. ICP is a platform, right? Our first market is looking at this cooling water recycling. We know there's the need, but what we do is low maintenance, low power water purification. So that's processed water, that's seawater desalination, drinking water, right? So this is really just the start. So we are looking for commercial partners to do more of those deployments, like I mentioned, and we're also raising a seed round. So I'll be in that pavilion after if you guys would like to talk. Thank you.
Thank you so much, Ben. I will now pass the mic to Dr. Paul Westerhoff, who most of you probably know. He's ASU's very own. But yeah, he's going to talk about his startup, H2O Optics Insights.
Great. Thanks, Paul. So, everyone knows what biofilms are. Those are the things that were on your teeth this morning before you brushed them. And they'll be there tonight and tomorrow and over and over and over. So this is kind of a minor, issue for us. We can manage it. But globally, biofilms and the control and the impacts of biofilms represent a $4 trillion problem. And it's the impacts of biofilms that we see, all around us. But whether it's biocorrosion on infrastructure or whether it's, medical devices, over 12,000 people a year die because of infections related to urinary catheters just in the US. Cooling towers have Legionella and all types of problems. Over a dozen people in Brooklyn died because of Legionella coming out of cooling towers. And of course, clogged pipes, mold in your houses, and many, many other things. So our company, our non-chemical solution to this is UV light. So the traditional way to control biofilms are putting in, as Nona said, lots of chemicals over and over and over. And so it works to partially do it, but we use UV light. We don't treat the water as it flows through a system. Our technology are side-emitting optical fibers that go on surfaces. So these are like glow sticks. They're thin, flexible, dynamic sources. You have one source of light. The fibers go on a surface, a single fiber or kind of a mesh of fibers to control biofilms where they grow. Kind of like braces on your teeth. These are optical fibers that are on surfaces. So the underlying magic here is not UV light. UV light, UVC, germicidal light has been known for decades to control and inactivate bacteria. It's really that we deliver light in a new way. We have these thin, flexible optical fibers that side emit light, again, like a glow stick. They're between 0.1 and 100 to 500 microns in diameter. They're thin, they're flexible. You can have single fibers or bundles of fibers attached to a single low-power light source. So we have patents on this that our company is licensed from SkySong. We have a partner right here in Phoenix, Molex. It's an optical fiber company. We can make over a kilometer of this fiber already at a time. So these work. We've done lots of simple demonstrations. A fiber in water kills E. coli. Again, it's just a different way to deliver light, like putting a little glow stick in a beaker on kind of wetted surfaces, like these agar plates. The top is mold, and right in the middle, there's no mold. So the optical fiber, you can hardly see it, is in the middle, and it creates about a 3 centimeter wide inhibition zone to control on the top fungal growth and on the bottom to control bacterial growth. We've done a lot of things on different surfaces. This is in kind of a submerged system on the right. The top one is stainless steel, and the green fluffy stuff on top is biofilm. So with a single fiber on the bottom one, we don't sterilize the surface, but we control the biofilm growth or inhibit it to less than 10 colony-forming units per square centimeter, well below the EPA recommended level of 100. So on the top, you can imagine that that stuff sloughs off and clogs all types of sensors and valves and other things. So we've done this. We've done field deployment through NASA. We've had a phase 1, phase 2, phase 2E, and a phase 3. This was part of the phase 2 with a company called Legionella Solutions in New Jersey. There's a cooling tower they're standing next to. So the cooling tower uses all types of chemicals. They use chlorine, but they still have detectable hits of Legionella in the water. And that's because as the cooling tower water in the basin goes up and down, when it's down, the biofilms on the wall grow, it comes up, shears them off, and then gets aerosolized. So that leads to violations as well as additional chemical needs. The bottom is an example of kind of point of use tubing. A single fiber inside of the tubing controls biofilm growth. So our fibers just came back from space. So our work was initially funded through SBIRs and STTRs with NASA. So we looked at controlling biofilm in microgravity. We have contracts now with Amentum to do this in water storage tanks on this space station. So come join us. I'm the CTO. My wife, Kelly, is the founder. We have other folks working with us here in the community. We'll have a new CEO coming soon. I can't show his picture yet. But what we ask you for today is to come up to our booth and tell you about, or you tell us about how you can integrate these fibers into your solution. So we really see integration of our fibers to control biofilms as the market we're after. So thank you very much.
Thank you so much, Paul. Next up is Watergenics. And for Watergenics, we have Heather. Heather.
Yeah, Heather Tegowan. I know I have a terrible last name. So welcome. Watergenics is transforming water quality sensing and data analytics. So we're in that bucket of the AI-driven water quality hardware. So we're kind of a mix of hardware, software. So right now we're playing in the sandbox of mining lithium and desalination, but I think we do have a lot of applicability to any high industrial water sources or water treatment processes. So we work in the dirtiest waters, we work in the high salinity, the places where things are precipitating readily, right? Like that's where we thrive, and that's where most sensors have never been able to go before. So that's one of our key advantages here. So here's some friends we're working with right now all over the world. and I'll get into what we actually do. So we do real-time chemistry, and I do have a booth upstairs also, so feel free to stop by for more information. We increase productivity of different industrial water processes, so whether that's throughput. In a lithium example, we're working at a mine, and we've been able to increase their actual yield of the metallurgy process. So that's an amazing win for the team. We're also working in treated water recovery and recycling. So on that, a different mining application, we're able to decrease their freshwater demand because they have to meet compliance metrics right on the back end. So in knowing real time what the water quality is, they can use less of that blended fresh water in order to meet their compliance requirements. So what we really want to do is get these sensors out into places where we can measure any of these parameters. We have a long list. Anything that's a molecule, we can in theory measure. We work in the ppm plus range, so that's important to know just from a concentration perspective. So I have a quiz upstairs for anyone who has an industry, application, and chemical. They want to give us a list. I have little Post-its. Please come up and put them down, because we will continue growing the list. We have 30 plus chemical and physical parameters right now. Again, with one probe, no reagents, no calibration, all of it is done electronically. We're using physics to measure chemistry. And so that's a bit of a different approach to how you've historically done things in a black box where there's little chemicals being poured in and doing UV vis or whatever absorption technologies. But we're taking tech that's built for the lab, putting it in the field, and really giving it that little maintenance that is required for some of these applications that are pretty remote. So we can also be on satellite, et cetera, if we're way out in the boonies. So this is our platform. We have an AI-based platform that churns through all the data. It is ML AI assisted, so we're able to pull all of the data in. It takes a fingerprint, so if we have retroactive interest in certain parameters, we can go back in and pull those out of the data because it's still there. So this is a unique aspect as well. Some of the ROI, we have really high ROI in a lot of different pieces. Obviously, we've talked a little bit today about reverse osmosis, one of the biggest treatment platforms of any use in industrial and municipal water. So decreasing the amount of chemicals on the input side, decreasing the amount of energy on the input side if you know how to not scale the membranes by knowing what chemicals to add and how much. Also increasing the lifespan of those membranes, which is the biggest turnover cost, especially in these industrial facilities. I was talking to one user who said they throw away their membranes every 2 weeks, and that's just a cost of doing business. Could be a month, then we're saving a lot of environmental damages as well on that. HDS or lime softening, so this is high density sludge, doing neutralization reactions for these high metallurgical solutions, really getting into how are we going to optimize dose if we're doing lime softening, right? So cooling towers out at the nuclear plant are using large lime softening clarifiers that are trying to knock down that salinity so they can get more cycles of concentration. So as we continue transforming how we're treating water, we need to think about how we're measuring water to be able to even treat it, right? So advancing those technological solutions. Here's a rundown of a lot of use cases. I have these printed up upstairs, so feel free to come by. But again, environmental protection, we're looking at a lot of solutions that are really in that optimization for plants and getting a tangible ROI back to those customers in the mining space. So they're getting net positive benefit from using our device, as well as general operational readiness and stability. So a few, especially in the lithium, again, I'll drive this one home, tens of millions of dollars in the lithium market just from a single sensor. So mitigates what impurities are in there, and then this one's really a revenue-driven application use case. So we have a few things that are kind of on the up and coming. We'd love to get anyone in RO doing any sort of surface and groundwater treatment. I know I've talked to a few municipalities, and it's just hard with contracting. But on the power production side, cooling water, evaporation, boilers, we have reactive silica, we have iron, we have sulfate bicarbonate. So those are all key parameters. And I know I'm really technical here, so I apologize. This is a chemistry one, so kudos to Bruce for breaking it down a bit on the biology side. I really appreciate that. So we have a lot of partnerships and awards. This is hundreds of thousands of hours of input, and we own all of the proprietary information, so that's all in-house. We've also been listed as the #1 innovative tech company in Berlin. So headquarters is in Berlin. I am in charge of North America. And this is what we see as the future of water quality analytics. So these are places right now that we have operations, and we will continue to, again, expand the global platform of our service. And I can show you some more if you come upstairs and check out the booth. But thank you.
Thank you so much to all the 3 startups for sharing the great work you're doing. I just want to quickly remind everyone, we do have 6 more startups that you can talk to up on the 2nd floor. So there are stairs from either side when you get out to get to the startup pavilion. We'll run it from 9 a.m. to 3 p.m., probably 1 p.m. because it is really hot outside today. So please go say hi to them during the breaks or during lunch. And that is all from us. Thank you so much.